Teardown time. This time a €4 smoke detector. It's of the Photoelectric variety, which I believe is superior to the ionizing type, which is more common. The Photoelectric type is better capable of detecting smouldering fires than the ionizing type. So let's have a look inside. So we have the unit itself, a PP3 battery and some screws, and of course a manual which nobody reads. And here we have the ceiling or wall mounting and the unit itself. Okay, well, let's take a look inside. So it came apart easily enough. There was 4 clips here, and what I initially missed, there was also a screw which is hidden by a quality sticker here. But once the screw was removed, it came apart very easily. The PCB is held in by these clips here, and this is the PCB. This black thing here is the actual sensor. We got 3 conductive springs that link to the piezo buzzer, and on the underside is an IC, and it's marked SEMIC, SEMIC, and the marking is CS2105GO-M12. I googled that and found absolutely nothing. But from experience, these chips that don't turn up any hits on Google tend to be cheap knockoff from other manufacturers. So I googled for photoelectric smoke detectors, and one of the first hits I saw was a chip from Freescale, the MC145012, and had a quick look at the pinout, and it looked suspiciously close to what I have here. For example, on pin 1 and pin 2 they're labelled C1 and C2, and looking here, pin 1 indeed does go to a capacitor labelled C1, and pin 2 does seem to be going to a capacitor labelled C2. So what else is going on here? Well, another thing I've learned is that a lot of these low-cost consumer devices tend to be based almost exactly on the reference design provided by the manufacturer. And sure enough, further down in this data sheet, there is a reference design here. And so looking at some of the major components, we have a battery, a 9-volt battery, yes. We have a polarity protection diode labelled D1, and sure enough there's a D1 there. There's also a 22 microfarad electrolytic labelled C4, and sure enough we have a 22 microfarad electrolytic labelled C4. We have, for example, an LED labelled D4, and then we have a D4 there. We have another electrolytic, say here, C5, 100 microfarads, and sure enough, that is a 100 microfarad, I think. I actually can't see, it's behind the, it's not visible there. But everything else looks absolutely identical. So the entire PCB has been reverse engineered without any effort. So how do these things work? Well, there's two types of a smoke alarm that are common. One is the ionization type, which uses a radioactive source, and this is the photoelectric type, which uses a LED and a photosensor and essentially looks for light scattered by smoke particles. So let's go through the theory of how these two sensors work. First, let's take a look at the ionizing smoke sensor. Okay, we have a voltage source, a battery or something like that, a current sensor, and then two plates. And in the gap between the two plates, there's a radioactivity source. It's an alpha emitter, and these alpha particles bombard the air in between the plates, and when that happens, the air molecule splits into a positive and a negative ion. The negative ions drift towards a positive plate, and the positive ions drift towards the negative plate. And this stream of ions sets up a current in the circuit. Now what happens is when smoke enters the gap between the plates, the smoke particles mop up the ions, causing a measurable and definite drop in the current in this circuit. And that drop will trigger the alarm. The photoelectric smoke sensors operate on a different principle. Okay, the idea here is we have an LED, usually a near-infrared emitter, in a chamber. This is a light-tight chamber, but importantly it is not airtight. It has these baffles which will let air circulate into the chamber, but will remove as much ambient light as possible. And the idea here is that this LED is the inside of this chamber is very black, so the light from this LED is mostly absorbed by the chamber, so very little of it really reaches this light detector here. This could be a phototransistor or photodiode. So when smoke enters the chamber, these smoke particles are illuminated in the beam and they scatter light down onto the photodetector. So when you notice a noticeable increase in light in current through this photodetector, that's a strong indication that there is smoke in the air. So let's take a look at the inside of one of these sensors. It comes off quite easily. There's just little plastic clips here that need to be unclipped. Okay, so here you can see the LED, and here we have all the baffles that if you look at it from the outside you can't actually see the chamber, but air can circulate into it. And here we have the photosensor. It's probably a phototransistor or something like that. Notice here there's a baffle here in the center that just makes sure that there's no direct illumination of the photosensor by the diode, the LED here. It's completely blocked. So when smoke enters the chamber through these baffles, it'll get caught in the beam of the LED and will reflect light back onto the photosensor here.